Continuing with our rigid transformations, we're going to look now into rotations. So rotations, it's a rigid transformation that moves every point of a pre-image through an angle of rotation about the center of rotation. The points are rotated in a given direction, either clockwise or counterclockwise around the center of rotation. So in this image right here, we're looking at a center of rotation. This is my pre-image, ABC. This is my image, A prime, B prime, C prime. And if it says here that either clockwise or counterclockwise, if we travel this direction, that would be a negative angle, negative rotation, a negative rotation. Whereas if we traveled this direction, that would be a positive angle or rotation. Okay, a little bit counterintuitive. Clockwise, right? This is clockwise is negative. And then, of course, counterclockwise is positive. So just keep that in mind when we talk about a rotation of a certain amount of angle, a certain amount of degrees. Is it positive or negative? Let's see, of course, things that we should be able to see too, that here, starting B and then B prime is where I ended up. And then just thinking about the center of rotation, there's some things that we can actually do that appear in the next image. But here, if we connect our points, this is an indication that we went 180 degrees, is that, it looks like the center of rotation, all of my connecting vertices, corresponding vertices, will pass through that center of rotation. But again, things that we'll identify here on this next image. Distance connecting corresponding vertices to each other. So we can list some here, but let's just look at it. So in this image, they've drawn it in. Some things that we can tell that we should know. We'll just think of this point right here, the center of rotation. It's a midpoint. It's a midpoint because this segment is going to be equal to that segment. So if I'm going to go ahead and label the midpoint, and we'll just call it midpoint M, okay? So I know then things that we've looked at before now is that segment CM is going to be congruent to segment C prime M. Okay, they're congruent because they're equidistant as they traveled about the origin, right? Traveled about the origin. The C is going to be the same distance. C is going to be the same distance from the center as C prime. So just that's what they're talking there. So, and the same thing goes. Segment BM and B prime M is going to be congruent because M is the midpoint. And then lastly, AM is going to be congruent to A prime M. So those kind of things that we can see and understand what's going on. So just keeping that, knowing, and then the angle of rotation. B rotated 180 degrees. A rotated 180 degrees because it made a straight line. C rotated 180 degrees. So they all rotated the same 180 degrees. Okay, so just looking at things there. And then here, performing those rotations. Again, everything is moving at the same in this 120 degrees. So if we were to get a protractor out and measure our paper, we would see that G to G prime is going to be 120 degrees. F to F prime is going to be 120 degrees. And lastly, E to E prime is going to be 120 degrees because it all moved the same distance, the same amount of rotation. So here, looking at this rotation on the coordinate plane, rotations require a center and angle rotation rotations require a center of rotation and an angle of rotation while preserving the angle measurements and side lengths. Okay, angle measurements and side lengths. Had to add that in there. I left it off my image, but just looking at this image, it appears to be, remember when I talked about reflections, if my image and pre-image were at the same location, then they were on the line of reflection. Well, the same thing here applies, that if my image and pre-image points are on the same location, then that is my center of rotation. So the center of rotation here happens to be the origin. The angle of rotation, well, hopefully we know some things, and let's just cover this real quick. If not, if I start off right here, and this is going to be 0 degrees, and I travel to right here, I have gone 90 degrees. Okay, so coming here would be 90 degrees. Over here, I would have had that straight line, so that would be 180 degrees. Continuing over here, I would be at 270 degrees. And then continuing over here, not a very good circle. I would be back at 0, or I would have traveled 360 degrees about the origin. That would be positive numbers. If I went back the other way and I traveled this, let me fill it in. I was traveling this direction and it was positive. If I went the opposites and I traveled this direction, that would be negative 90 degrees, or clockwise, negative 180 degrees, negative 270 degrees, and then negative 360 degrees, or 0, back to my starting point. So the angle of rotation as I traveled, in this case, I went from here over to here. I traveled a 90-degree rotation positive, or I could say, for some reason, I could say 270 degrees negative. It would be the same location. The pre-image is going to be A, B, C, D, and then the new image should be A prime, B prime, C prime, and D prime. So that's what they're asking you, to be able to look at those things and identify those characteristics. Here in example number 2, here's some mapping for us. If we rotate about the origin 90 degrees, they're saying, hey, my mapping would be XY maps to negative YX. If we rotate 180 degrees about the origin, my XY would map to negative X, negative Y. If I go about the origin 270 degrees, my mapping would be Y, negative X. And then here I have rotating around the origin 360 degrees. We just end up right where we started from. XY remains XY. So as we look at this, and I've put in some of the points here for A. Looks like A prime is going to be A prime is going to be my first rotation, and as we traveled from there to there, that would be 90 degrees. So looking at that, my new value should be negative 4. A prime is going to be negative 4, 1. And if I travel 90 degrees about the origin, my mapping is going to be I've already put the answer in there. Let's see here. Mapping about the origin, I would have A is 1, 4, and that maps to A prime, which is going to this is going to be opposite Y, so my Y was 4, so it's going to be negative 4, and then my old X value is going to be my new Y value, which was 1. So there you go, that would be A prime. And then once you get to this point, you could do all of them together. You could do the mapping for all your points, but I would hope that you could see and fill in the rest of that information once you had the initial point. And again, as we rotate, let's see, if I wanted to go 180 degrees from my start, A1 or A is going to be 1, 4 again, and then A double prime, if I'm going all the way over here, like a bam, from there to there, that would have traveled 180 degrees. So A double prime, I would use this mapping, so my X is going to change signs. So I went from -4 to a -4, and then 1 to a -1, or should I say that A double prime should be 4, -1. Okay, and that looks like, does that look right? Absolutely not, because for some reason I decided to switch those. I am crazy. Let's see, let me fix that. Didn't seem right. Because there's nothing about switching, alternating my signs, right? I was just changing the signs. So this should be a -1 and a -4. Okay, so -1, -4. And sure enough, that's what we have here. And you can probably fill in the remainder of that triangle without too much effort. And then finally, if we were to do that last rotation where we went from here all the way to here, that would be 270 degrees. And again, A started off as 1, 4, and as we map to a triple prime, my Y value is going to be the new X value, so it's going to be 4. And then I'm going to have the opposite X value, so the X value used to be 1, so it's going to be a -1. Okay, so that's how we could do that mapping. That's how we were able to calculate that information. Okay. And then to the fourth right here, it looks like we would just end up right back where we started. So A to the fourth, A to 4 prime is going to be simply 1, 4, because we ended up where we started. All right, so move here and copy this real quick. Take this and move this forward for us. On here, looking at this, what rule describes the rotation about the origin from the pre-image to the image? How many degrees about the origin was figured? Let me go back. So we have that as reference now. Okay. So looking at that, what rule describes the rotation about the origin with the pre-image to the image? How many degrees should the origin about the origin was the figure rotated? So let's see, we started off here, this is my pre-image, and then we either went this direction, which would be 270 degrees positive. Let's say I went 270 degrees positive, or maybe you look at that and say, well, technically I went 90 negative. We just need to know that this is going to be my mapping rule right here. So it should be XY mapped to Y negative X. And if we look at one of those points, if we pick point R is 4, -1. And it mapped to R prime, which was, looks like -1, -4. Okay, and if you look and see what happened, my old Y value is now my X value, just like it calls for. And then my old X value is my Y value, but we've changed the sign. It used to be a +4, now it's a -4 because it's asking us to do that. So there you go. This is your mapping rule. And of course, it just depends, we can do some interpretations there. Okay. Same rule applies here. What if, in example number 4, what is the image of triangle DEF after a 270 degree rotation? Again, we are looking at that rotation where XY maps to y negative x, okay? 270 degrees, that would be positive, so we would go 90, we would go 180, and then 270. So we are going to be in this quadrant. Again, a lot of ways that you could do this. It's just whatever you're more comfortable with. But I could turn around and plot each one of those points and do the transformations. All right, so go ahead and do that transformation. I had D, E, and F. I went ahead and took the points off the coordinate plane, and then I know my transformation is going to be, I'm going to switch my y and x's, and then the x is going to become negative. So all of my y values became my x values, and then I have the opposite of the x value, the opposite of the x value, the opposite of the x value. So those points should actually be D prime is 2, 5. E prime is going to be 2, 1. And then F prime is going to be 4, 3. So let's see here, 2, 5, 2, 1, and 4, 3. There you go. That's my new graph, my new, my image, right? My image. So this is F prime, this should be D prime, and this should be E prime. So there you go. There's my pre-image and my image, my pre-image and my image after a 270 degree rotation. Let's see here, negative 90. Goodness, that's going to be 270 degrees. Negative 90 and a positive 270 are the same. So again, xy maps to y negative x. What is the pre-image of the figure if the rule that created that image is this? Okay, so that's what we did. So let's see here. What could xy be if, pick a point. I'm going to pick S prime. S prime is going to be 2, 4. And that should be S prime is going to be 2, and this is going to be a negative 4. Because it's calling for a negative in the mapping. So that's why I did that. Negative times a negative would give me that positive. So it looks like this should be my old y value. This should be my old x value. So in this case, S prime should be negative 4 and 2. So we would be at negative 4 and 2. That should be my original S value. So, and we could do that same kind of transformation with each one of them and see what happened. Or maybe when you get to this point, you have enough where you're like, I think I can just draw that in. I can just draw that in and call it good. Oops. There you go. And here, rotation 90 degrees about the origin. Oh, thank goodness it's not 270 this time. Rotation 90 degrees. There you go, negative yx. Okay. xy maps to negative yx. After a rotation of 90 degrees about the origin, the coordinates of the vertices of the image of the triangle are this, and this. That's my new image. What are the coordinates of the vertices of the pre-image? Okay, so again, if I take this and I say C prime is 1, 7, you got to think about that. This is where we are. It should be a C prime is negative 1, and then 7. So this is going to be my x value, this is going to be my y value. So therefore, C should have been 7, negative 1. And let's see here, the B value, B prime is negative 2, 1, or it is, again, negative 2, and then 1, because so this is my x value, this is my y value, so B should be 1, 2, and then last A prime was 6, 3, and or that should be negative negative 6, because that's going to be my y value, and 3, that's going to be my x value. So A started off at 3, negative 6. So there you go. That's being able to determine that pre-image based off your image and your rotation mapping. All right, so what did we or did we not cover? Rotations, they've given you some examples telling you that these two things are equidistant, the same length. Here's the mappings that we just discussed. Vertices, they're doing some rotation about a point that is not the origin. We are not going to do that in this class, okay? But understand that there's a way to accomplish that. It's just a little bit beyond where we need to be. Or should I say where we need to be for the state of Tennessee in this current class. Let's see here, doing this check. Again, not going to worry too much about beyond the origin. And then see here, describe the rotation effect. Kendrick is working with a team in his social studies class to create a new country and its government. Kendrick is responsible for creating the country's flag. He is using geometry software to design the flag on the coordinate plane. Describe how the two yellow stars would be affected if they were rotated 90 degrees counterclockwise about the center of the white star. All right, counterclockwise. Counterclockwise is this direction. So if those stars, let's see, we're going to go around that. So if I rotate it, I'm going to rotate 90 degrees counterclockwise. So it's going to end up, that star should end up over here because we're going to travel that 90 degrees. And the same thing with this other star. If we traveled 90 degrees with it, it should have ended up right there, because that also would be 90 degrees. So just thinking about where it would have moved to. Estimating, of course. So just thinking about as we move that 90 degrees counterclockwise. And then here, representing rotations, it looks like we have covered the same amount of information, talking about the concepts of rotations, thinking about how far they travel, 90 degrees, 180 degrees, 270 degrees, talking about clockwise and counterclockwise. And then here, would two successive 90-degree rotations counterclockwise about the origin result in the same image as a 180-degree rotation clockwise about the origin? Yes. And think about it, let's see, using this as an example, start off here and we go 90 degrees and then we go another 90 degrees, puts us right there. So there's 90 plus 90 would be the same thing as if I went 180 this way, because there's only 360 degrees, so the other 90 the opposite direction would, 80 the opposite direction was put us back in the same spot. All right, so rotation, but let's go look again. Right here, y negative x. And then last but not least, let's see here, rotations. We're doing the same kind of information here. We're using our mapping. And that's really about it. So we are, let's see, we'll do this one real quick. Fix this, check quadrilateral JKLM and its coordinates. So here's my original pre-image coordinates. Determine the coordinates of the vertices of the image after a 270-degree rotation. Well, we did that 270 degree. All right, so xy maps to y negative x. Just pick one point. Pick J. J is 1, 2, and it maps J prime, should be mapped to my y value, right, is my new x value. And then this is going to be negative x. X is 1, so it's going to be negative x. So J prime should be 2, negative 1, 2, negative 1, and it looks like that is the only possible solution there out of my multiple choice answers. So there you go, just sort of thinking about using our rotations, put these maps on your cheat sheet for your test. It's going to help you a lot as you practice with it. But that's it. So we're going to dive deeper into our rotations.